Hello folks, I am Miss Armgart. Welcome to our video for task 411. I can show understanding of dividing fractions through the use of a model. We've already done integer by fraction by integer. Now, fraction by fraction. So there are two different models you'll see on here. We have one up here, the second one down here. We are going to take those one at a time, and you are going to choose the one that makes the most sense to you. We're going to look at drawing one in the same picture first. So, step number one, draw a picture that represents the dividend, the first fraction, 3/4. So this box is split into 4 pieces. We are going to color in 3 out of the 4. You can use a highlighter, your pencil, you know the drill. Now have to draw the divisor, 3/5, so each of these is split into 1, 2, 3, 4, 5. They don't have to be perfect, folks. They just have to represent the fraction. Each fourth is now subdivided into fifths. So, how do we figure out how many 3/5 are in 3/4? You'll notice we now have 20 different sections in this box. That happens to be our LCM is 20. So on these fractions down here, we can actually count. We know that 15, count those boxes, 15 of the 20 boxes are shaded for 3/4. Brilliant. So I can make an equivalent fraction of 3/5, 3/5, because I know 5 times 4 is 20. So 3 times 4 is 12. So now we have 15/20 divided by 12/20. We have our equivalent fractions. Our regrouping, because remember, the divisor right here is how many of those groups are in our original fraction. So how many 12/20s are in 15/20? Oh, well, we can do that. We can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 right here. So now our new grouping, because we're looking for groups of 12, we have one group of 12. We have these 3 pieces left over here. So we know that one group of 12, and we have 3 out of our 12 left over. We've got 1, 2, 3 colored in pieces left. So let's simplify that fraction to 1 and 1/4. So this model has both fractions in the same model. Let's look at our second one. So this first rectangle, we're going to split into 4s. To keep my brain on track, I like to put the fraction next to it. I also like to color code. And then what are we going to do? The same that we always do. We are going to shade in however many it says. And for this one, it is 3/4. So we're going to shade that in. Now, the difference comes because now we have to deal with our 3/5 in our second box. So our 3/5, so we have to divide into 5 pieces. Again, doesn't have to be perfect. Once you divide into your 5 pieces, you're going to shade in 3 of them, just like we've been doing. After we shade them in, we need to represent the other fraction in the same box. So for our 3/4, we have to go across. We're going to divide this into fifths. And for the 3/5 box, we need to divide this into fourths. Each box has to have the same number. In this case, each box has 20 squares. So they each have the same. Notice how we're making equivalent fractions just with a picture. Now, in our directions, we need to find the number that are shaded in the first square and the number that are shaded in the second square. So we're literally just going to count that. We have 1, 2, 3, 6, 9, just doing multiples of 3 here, 12, and 15. So the total in the first square is 15. We have 1, 2, 3, 6, 9, 12. We have 12 in the second. So all we've done is count the number of squares that are shaded for each of our diagrams. Simplify this, because 3 is a factor of both. We get 5 over 4, or 1 over 1 and 1/4. So you'll notice both models gave us the same answer, so it doesn't matter which one you like better. You just have to use it and show it on your MCQ and our standard check. So once again, folks, there is model down there. Draw or write an example. Happy math.